everybody. Thank you for coming on what down here down the south of England is a very sunny day today. So giving up some time to come and talk a little bit about problem solving is very much appreciated. You're very welcome. Just a little bit about us today before we start. So I'm Becky. I am one of 3 educational content leads on primary maths here at Twinkl. I have just over 20 years teaching experience, mainly Key Stage 2, and did a little bit of maths leadership as well in there. And I've been working at Twinkl on the maths team in various roles for the last 4 years or so. John, would you like to introduce yourself?
Yeah, thanks, Becky. So my name's John Cripwell. I am the National Educational Lead for Primary Maths here at Twinkl. Worked at Twinkl for just over a year now. And prior to that, I was predominantly a Year 6 teacher, I have to say, although I did work across the rest of school as well. Assistant head teacher, did a little bit of work at trust level as well, and maths lead, of course, for most of my teaching career. And now working at Twinkl as National Education Lead alongside Becky, and of course Becky, not forgetting our most important work that we do at Twinkl, which is of course as joint hosts of the Primary Maths podcast. So you can listen to Becky and I every week on that, wherever you get your podcast. There's my little plug for the podcast, Becky, before we even start.
Thank you, John. Yes, if anybody's found it already, you'll be used to me and John having little chats about maths. But if you haven't, it's a great listen, so do go and find it. So today's TeachMeet is actually the second in a group of what will eventually be 6 TeachMeets covering the really important topic of maths problem solving. This one is specifically about working systematically. If you missed the first one on pattern spotting, you can find the recording on the Twinkl website on the TeachMeet section, and there will be some more, so do keep your eyes peeled on Eventbrite for those. So today's topic then is working systematically, but we will start by just reminding ourselves what the issue is with problem solving in maths currently and the importance of teaching problem solving explicitly. We'll then go a little bit more detail about working systematically. It's a fairly common term in maths primary teaching, but we'll talk about what it really is and why it matters. We'll break down the skills involved in it a little bit more. We'll look at what that might look like and the progression from year 1 through to year 6. And then we'll break down some of those sub-skills a little bit further, talking about the need for a certain approach, recording, key questions, and so on. And then we'll finish with just sharing a few resources for you that you might find useful on your problem-solving journey. There will be, as James mentioned, a Q&A at the end. So if you've got any questions, please do ask them, and we will have some time at the end, hopefully, to answer those. I'm going to pass back to John now to talk a little bit about problem solving in general. Thanks, John.
Yeah, thanks, Becky. So we know that problem solving has been a bit of a challenge in maths for pretty much as long as anybody has been teaching maths. It's one thing to teach a particular concept, such as how to multiply one number by another number to find its product, but then we add in the added layer or cognitive load of trying to solve problems with it, and we find at that point that lots of people, children and adults, can find that the actual problem solving itself can be a little bit of a barrier. When I first started at Twinkl, I was really keen to see if we could do something to help teachers actually help their pupils to become better problem solvers. And I was delighted to find out that Becky was already working on something, and this is essentially what that is. So what is the problem with problem solving? Well, I think, first of all, one of the issues, I don't know if you agree, Becky, but it tends to be that there's, when we think about problem solving, lots of teachers, lots of pupils, lots of parents tend to focus on word problems and see problem solving as very much a word problem issue. Whereas we know that actually within maths, problem solving can involve all sorts of different activities. And when you look at something like the Key Stage 2 reasoning papers, only a fairly small proportion of those problems within there are actually word problems. Lots of them take a different format entirely. Sorry, yeah, go on, Becky.
Yeah, when I was doing some research, doing a lot of research on problem solving, I spoke to a lot of teachers over the last couple of years or so. And when you first ask people what they do in problem solving for maths, I think that's the first thought. The first thought is what word problems do we do? So it's trying and shift that understanding away from just that word problems really, but certainly is something which most people think of when they think of problem solving, I think, is a worded problem.
Yeah, definitely. And then quite often we see problem solving as something that's left till the last part of a lesson. So not all children necessarily get onto the problem solving part of the lesson. Or sometimes it's not even part of the lesson, it's an extension to the main lesson. And it's there for as an activity for pupils who finish the rest of the work more quickly than others. Problem solving is sometimes seen as something completely separate to the rest of the maths lesson. Whereas, to my mind, I don't know if you agree, Becky, but problem solving is sort of almost one of the purposes of doing maths. It's all about problem solving, and problem solving should be integral to the lesson, really. But one of the reasons I think it's sometimes not is that we're not always clear how to actually teach how to solve the problem. We can teach the maths, and we've got some brilliant resources to help us to teach the maths. But in terms of actually how do we teach those problem solving skills, that's something I think that hasn't been addressed particularly well over the last 10 or 15 years, certainly. And quite often we hear about we can either teach through problem solving or we can try and teach problem solving. And I think quite often we try to teach through problem solving rather than teach the actual skills of problem solving itself. And part of that is because there hasn't been a huge amount of CPD available for how to actually teach the skills of problem solving. So that's what this series of webinars really has been designed to help you with as educators. So this is the second in a sequence. If you missed the first one, it should be available on site if you're a Twinkl member to go back and have a look at in the TeachMeet sessions and section of the website. And then we've got 4 more coming up after this one as well. So the previous one covered how to help children spot patterns and what to do with them when they have spotted those patterns. This one is obviously about working systematically. Then we've got other sections coming up on using models, trialing and improvement, changing the process, and making connections. And the problem solving journey that we hope that you and any children that you work with go on is the idea that if we actually teach how to the strategies to help children to access problems, we give them a problem solving toolkit, if you like, where they can select the right strategies to use, and then they can apply those to at first to similar problems, the sorts of problems that they've seen before, and then eventually to non-routine problems, moving on to the sorts of problems that they may not have encountered before. And this allows obviously for discussion and reasoning about which strategies are we going to use from our toolkit, how are we going to combine those together, where are we going to start, and do we need more than one, and why are we using those ones? Eventually leading to a place where pupils are choosing for themselves the right strategy in order to access the problem in the best possible way.
I think often we talk about problem solving, and one of the biggest issues I think we face as educators is resilience, isn't it, John? And children being able to get started and stay put when solving a problem. So by providing this toolkit, we're hoping that children will be much more resilient when faced with some maybe less usual problems, as well as the ones that they'll be used to seeing.
Yeah, I think that's a really important point, actually, Becky. Whenever I'm doing training in person with teachers, I always ask them what they think a good mathematician looks like, and resilience and problem solving is always up there. My question is always, how do we develop that then? And I think this is a great way of doing that, and particularly trial and improvement, trial and improvement and working systematically, I think are both, as we were saying earlier, Becky, in our conversation before this, really critical parts of developing resilience and creating a resilient mathematician.
Yeah, thanks, John. So working systematically then, I feel like it's a term we probably do use with pupils quite often, but it's really important that we are ensuring that the children know what we mean by that. It's about finding that logical starting point working through in a way to ensure that the problem's completely solved. And one way we can do that often, the sorts of problems that we might be faced with where we would encourage children to work systematically, might be where we're finding all possibilities. We talk a lot about the importance of jottings. We were talking just last week on the podcast about a maths installation celebrating women in maths, and there's a great part of that installation which is a piece of artwork involving lots of jottings from various female mathematicians through time. And jottings absolutely have a place in maths, but there probably has to come a time when those jottings might need to become a little bit more organised. After that sort of initial idea generation, a little bit more of an ordered way might be important. And problem solving has been talked about a lot. The curriculum assessment review from the Department for Education highlighted that problem solving is a critical gap. It is a gap, and being able to work systematically is a really, as John said, a really key step towards that confident and robust problem solving. It also tends to use pictorial representations, whether it's a table or a chart or something like that, that does help, particularly with a more abstract concept. So helping to reveal the structure behind the maths in that way. It also helps to break down the process. Again, working systematically as a strategy on its own wouldn't necessarily solve the problem, but drawing on other areas of the toolkit as well, it can help to break that problem down, so you're just doing one step at a time, which we know maths anxiety is a real problem in today's classrooms, so it can help with that as well. And it does support that use of formal recording methods and how we move from that initial what could be messy maths and the importance of that, but how to move on to a more robust, organised approach. So working systematically really is, although I think we were saying earlier today, John, weren't we, that it's sort of gone out of favour a little bit. Maybe we don't hear about it as much now.
Yeah, that's right. Certainly, it feels almost like it's something that we do just before SATs. Oh, this is the sort of question where you might need to find all the possibilities. Therefore, we need to work in some sort of systematic way. Or when it comes to learning algebra in year 6, we need to work in some sort of systematic way in order to find the pattern that's going to help us unlock the rest of it. But as you say, Becky, this is a skill that really starts right back, even in EYFS, really, as we'll see as we go through.
Yeah, absolutely. Yes. So as John said, working systematically isn't just finding all possible solutions or all possible unknowns, but it starts actually very way back at the beginning of a mathematical journey, probably even before children get to school, with quite straightforward sorting. If you're able to sort things, you can be systematic. You must have a systematic way if you're sorting. It might not be the way that you would think, and it's really important that we're giving very young children opportunities to sort in ways that they prefer, and being able to explain the way they've sorted, even if it doesn't quite fit what we think would be the correct way to sort things. So, for example, you might use some objects that range in colour, but also range in size. Possibly you might add a third option of shape later on, thinking about the different ways you might sort those things. And then eventually how you might then order the way you've sorted them could be the next step through sort of going through Key Stage 1. And ultimately, we're moving towards finding that suitable starting point. And then once you've got a starting point, making that one change at a time to make sure that we're very systematic, very tiny steps, thinking about how we might record that. And that recording will go all the way through the ages. It might look a little bit different at year 1 as it does in year 6, but that recording, as we'll talk about later, is really important. And then, of course, we've already mentioned finding all the possible solutions. And the next step in that, you could set children out on a problem where they're finding all the possible mixes of ice cream flavours, for example, within a given parameter, and they might go about it in a very random way. But eventually we need to talk about how working systematically can help us to prove, and that's that proof and that justification that we found all possibilities, and why that approach can tell us that we found them all. And then eventually, moving on through up to year 6, they might start making generalisations and possibly finding formula as well. They may not call it that, but that will certainly be the sort of things that we'd expect to see when children are working systematically. So there's just 9 things on the screen. There's probably even more subsectors there, but different skills that make up this working systematically, which is a phrase we use often, but I don't think we often unpick it enough. So taking that previous slide, then we have in our new collection of problem solving resources at Twinkl created a suggested skills progression. So you can see on the screen there, moving from sorting, finding starting points, all the way through creating systematic lists, beginning to use patterns, and we'll talk a little bit more about how working systematically and spotting patterns are linked together later. Also then thinking about efficiency. If you're going to randomly find all the possibilities, you might eventually find them all, but it probably isn't the most efficient way to find them all. Thinking about doing a pentominoes investigation, I'm sure we're familiar with that, different ways we might join together 5 squares, having to find all the different possibilities, and often it can be quite tricky to work out, have I had that one before, is it the same way but the other way around? So being able to be sure that we've worked in a way that we found them all, and then, as we said before, working all the way up to year 6, where we definitely will be using systematic problem solving through subjects such as algebra. This is just a visual example for you, really, from our new resource collection, which you can find on the Twinkl website if you're a subscriber. You can see there, starting with year 1 on the left, in a very simple sorting type problem and helping to sort in different ways. And you can see there's a few different options there. There are different types of leaf, colour and decoration. Moving on to a different context there with tense, and you can see a bit more words in those questions. All of our activity sheets have an animation that goes alongside them to reduce that initial reading load. So the reading is there to support, but hopefully you would use an animation to introduce that problem too. And then finally up to looking at different combinations in year 6, and you can see, you might be able to see there's a few different units as well. It's just a little visual representation of how we've used that progression within our resources at Twinkl. So John, I'm going to hand back to you to start talking about some of the individual skills. Then we'll start with finding a starting point.
Yeah, and probably finding a starting point is one of the most important parts, isn't it? Because it's often the bit that pupils find trickiest, just not knowing where to start. And that's where I think working systematically can help us try and identify the best place to start. And that might be taught through presenting a problem and discussing around where would you start, why would you start there, what might be the best place to start here, what do we know, what do we want to find out, let's start with what we know, and evaluate the best possible starting points using that sort of discussion to help us to identify them, and then think about different routes through the problem. And again, this comes back to the idea of resilience. We need to start on one route knowing that it might not actually be the best route, and we might need to stop and go backwards before we can carry on going forwards, and creating an environment with the children that we're working with to say that that's okay. We're working systematically, nothing that we're doing is wasted, and actually, we're making progress, even if it appears that we're going backwards a little bit sometimes. So having those opportunities to think about the starting point, and considering whether where we started affected the result in the end is really important. Once we've identified the starting point, we might also need to identify whether we actually need to work systematically through this problem. And there are little clues within the problems that will help us with that. So, for example, it could be that there is a lot of information given in the problem, a lot of numbers, a lot of data, or just a lot of words sometimes, that we might need to work systematically through that problem. It could be a problem where it says or suggests in the question itself that we need to find all the different possibilities, and that might give us a clue that working systematically or creating a system to work through this problem might be the best approach here. Or we've talked about pattern spotting a few weeks ago in the previous webinar. Sometimes we need to have a system to help us actually identify what that pattern is, and the way that we record what we're doing and the data that we uncover doing that might well give us a clue as to what we need to do and how we need to uncover any potential patterns within the data.
Brings us on beautifully to the role of recording. Thanks, John.
Almost like we planned that, Becky. Almost.
Lovely segue there. The role of recording is really important in working systematically. As I said, the initial idea generation and, you know, the importance, as John was saying, of just making a start, even if it's not the right one. There's a place for that, but eventually we probably do need to think about recording in a way where we can hopefully spot a pattern or spot what's happening to make our problem solving more efficient. So logical lists are a good start, and then tables and charts, which children will be familiar with. Obviously they are taught about tables explicitly in the curriculum, but they will have seen them long before we start talking about them. So thinking about how we might record things in a way to draw out those patterns, using physical manipulatives alongside that recording. So recording, although it's visual, as you can see there's lots of numbers there, it still could be quite abstract. So actually having those physical manipulatives, this problem is about having 3 different components. In this case, it's water bottles, compasses and rope, and making a total of 18. And there are some other parameters in the problem as well. So it could be that you have physical apparatus. I mean, not suggesting you necessarily use water bottles, compasses and rope, but you could, you know, use models at that point to think about having maybe different colors to represent different things to support that systematic problem. And that can really help to bridge the gap between concrete action and that really quite abstract thinking, which is really tricky for young children. And then it's thinking about, within that recording, not changing too much. So in the example you can see on the screen there, we're keeping the number of water bottles the same and we're changing the other components. So in order to make sure that we stay systematic, we're making really careful choices and we're modelling that for the children. And that's really important that teachers and educators are doing that as well, modelling what might stay the same. And of course, continuing those discussions around choice. You know, well, would it have mattered if I chose to keep the compasses the same? Well, probably not. That might be something that you need to evaluate at the end, when maybe 2 different people have had a different approach. You can compare them. But certainly teaching about just changing one variable at a time when you're recording, to make sure that we can really draw out any patterns and help with efficient problem solving. We've talked a little bit already about resilience, and systematic fatigue is a term I quite liked, but it was about if you had lots of options. So you can see here, this is a visual representation of a torch problem where torches were flashing different colours. There were 4 colour options and there were 3 flashes of light. But if children were finding them and if they weren't yet working at a very systematic way, they could get a little bit tired of finding them. I mentioned pentominoes before, done that lots of times. Children coming with the sheet saying, "Have I found them yet? Have I found them yet? Please, have I found them yet? Please." And then the great excitement of having found one that they haven't found yet. But it can be quite tiring because it's not instant gratification necessarily with a longer problem like this, and children like that, don't they? So sometimes not being able to find the problem straight away is hard, but that challenge is an important part of the problem.
I think that's a really good example, that sort of problem as well, Becky, of where the solution isn't necessarily obvious from what's involved, because, you know, the answer, as you've got there at the bottom, is 6 + 6 + 6 + 6, or 4 times 6, 4 lots of 6. But in terms of what's involved, we've only got 3 different colour counters. So looking at the numbers that are involved doesn't really help us to find the solution necessarily. So working systematically obviously is really important in this kind of problem. But again, you don't want to necessarily, as you just said, work it or do the whole thing in that way. We're looking for the easiest way to get to the solution, aren't we?
Yeah, absolutely. And you can see there, because of the systematic way, on the left hand side you've got the flashes starting with the red colour, and you can see then you've got 2 that have green next, 2 that have blue next, 2 that have yellow next. Well, children might then start on the next starting colour, which in this case is green, and spot that it's the same, but the colours are swapped. So there's another 6. At that point they might say, well, I don't need to find the ones for blue and yellow because I know that it's 6, and therefore we've encouraged a bit of pattern spotting through working systematically, which is a really efficient way of working. And there will be children, of course, that will want to sit there and find them all, or maybe won't be quite ready for that. But it's important that we're encouraging and modelling that systematic working for those reasons, and that's a lovely visual way of showing why that's important. So children, as I said earlier, I spoke to a lot of educators around the area of problem solving, and lots of them were telling me tales of particularly around the area of resilience and perseverance, tales of crying children or sad children. Obviously, that's not what we want in a maths lesson, particularly what could be a really great maths lesson. We want to build children's confidence. So it's really important that we're building up that resilience and perseverance. And we can start that by modelling the questions that you might ask. And through our resources, we are trying to be quite consistent with the key questions we use, so that eventually the teacher starts by modelling them and using them. Then eventually the children can then start asking each other during some peer discussion, and hopefully eventually then move on to independence and asking themselves these questions. And some of these questions will be familiar because they're sort of reasoning type questions, or questions that are related to other strategies as well. Asking what would be a sensible starting point, where are we going to start, and then being brave in having a starting point, and an awareness of the fact that we might have to go back if it wasn't quite the right way, and that being absolutely fine. What you're going to keep the same each time and what you'll change, so thinking back to those colours, maybe starting just with red. How we're going to keep track of the solutions. Now, there are formal ways, of course, but children may also start developing their own ways, and although we want to be able for them to be able to use their ways of recording to spot patterns, that doesn't mean it has to look a very particular way. So be open to those sorts of ways that the children might find to keep track of their solutions as well. And then we can start to ask questions like, well, how do we know we haven't missed any? How do we know that we've got them all? Can you spot a pattern? And some children will instantly see it, and some might need a little bit of prompting. And then starting to use that for asking them to maybe, can you make a prediction? In a similar way with the torches problem, if you were halfway through and you just got the red and green, that might be a good place for an interjection from an educator to say, well, can you use this to make a prediction? Children won't necessarily know to do that themselves to start with, although the idea is that that's where we want to get to eventually with some independent problem solving. Working systematically is something we do see in the curriculum a lot. I've just put on the screen there some examples through various resources of the types of problems that we might be familiar with in working systematically. Good old missing number problems, or someone's thrown their digit cards on the floor and has to fit them back in. I mean, these are great problems because they're also great for early finishers. They're really supporting understanding, a bit more open-ended. So things with missing problems, missing numbers, either like the top one, which I think is a year 1 example, and then the bottom one, which is a little bit more complex. But also finding all the possibilities, and problems don't always have to ask to find all the possibilities. This one is just said find 3, but children might have to work systematically to find those 3, and an extension might be, can you find them all? I don't know, I haven't worked out the answer to this one. It could take far too long, but thinking about whether it is possible to find them all. Then, of course, we're moving on to algebra, as you can see in the bottom example. So we do come across working systematically in the curriculum quite a lot. And I think we often just expect children to be able to do it. Well, work systematically and find the answer. We really do need, as we said right at the beginning of the session, to make sure we are explicitly teaching children how they might do that. Which brings us on to a little bit of sharing. So if you're a Twinkl subscriber, there are some resources that can help you. Hopefully everything we've talked about so far in the session is applicable regardless of which math scheme you're using or which resources you use. But we have been working very hard to create a new collection of resources that is specifically designed to teach strategies and help you on your journey towards confident and independent problem solving. So I mentioned earlier that our resources include animated introduction. Initial reading load can be a real barrier to problem solving. John was mentioning before, there's lots of barriers there might be that are not just the maths, and reading is certainly one that lots of people I talked to had an issue with. So we have tried to reduce that initial load by introducing our problems through animations with our jungle characters. We've also adopted, and this is great regardless of which resource you're using, a 4-step approach within, which is quite a famous approach to problem solving, which is understand, then plan, then solve, and then reflect. I think reflect sometimes gets missed off, and we've mentioned it a few times in today's webinar, the importance of going back and evaluating. So that's a really, really important, crucial step to the problem solving process, which hopefully will be repeated. I don't know the experience of the people in the room, but certainly when I started teaching, we had a problem a week to solve. So maybe at the end of the week, I think, John, I think you've described them as fun Fridays.
Yeah, fun Fridays, Becky. That was where it was.
Yeah, and I think that making sure we keep coming back to problems is really important. Maybe not quite as rigidly as that, but certainly I think we've lost that a little bit. The curriculum time is very, very tight, isn't it? So, but reflecting is going to be important when you come back to the beginning of a new problem. We've got comprehensive teacher walkthroughs. We know that educator CPD is an area which there's not much out there to support. So our comprehensive walkthrough talks through the teaching slides for the teacher, giving ideas for questioning and so on. And we also have a strategy guide for each strategy. So you can see there we've got our working systematically one. And of course, this webinar, which is talking about the strategy in a bit more detail. We are introducing the problem through a teacher-led problem. So there's a set of slides which basically help you. We've mentioned a few times about the importance of modelling, which will help the teacher to model a problem, including loads and loads of questions to prompt discussion. We know that oracy is really important in maths, and is certainly something which people are talking about a lot more now. So making sure that the whole class are involved in that discussion and using key questions to keep them involved. Also, we have decided that the maths content in these resources is maths content from a previous year group. We were talking earlier about the SATs and how actually SATs content isn't just year 6 content, it's drawing on previous content. So I think we sometimes forget that, but in order to make it so that this can be taught at any time in the year, we have specifically used maths content from previous year groups so that the focus can be on teaching the strategy rather than the maths. And each of our problems, both our teacher-led problem and our pupil practice problem, which is a sort of follow-up, include what-if questions. The value of what if is massive in problem solving, making sure there's enough for further exploration. Some children, as we know, will race through problems, will need a little bit more of a challenge, and eventually in a really strong problem solving classroom, you might get to the point where children are asking their own what if questions as well, which is great. And teachers are very good at doing that on the spot. We provided some just to try to relieve some of that anxiety around on the spot thinking. So this is the second of 2 units. They're both up on the Twinkl website, and you can see there, subscriber, you can go to twinkl.co.uk/maths-problem-solving and find the resources, or scan the QR code there. We have got 2 units on site already, with another one coming in a few weeks' time. Slight break over the summer holidays so everyone can have a little bit of a rest, and then back in September with our unit 4. All of the units will be on site by November, and there is a big bank of additional problems also coming in September, so that you can dip in and out of them for homeworks or Fun Fridays or however you want to teach your problem solving. So hopefully this webinar has taught you a little bit about, or reminded you maybe a little bit about, the importance of working systematically. You don't have to use our resources. Hopefully you've got enough to take with you that you might use regardless of how you approach maths in your classrooms. But if you do fancy checking out the resources, they do look fantastic, and the link is there for you. Anything else you want to add before we finish off, John?
No, I think that's pretty much covered it, Becky.